To help you Algebra 1 students prepare for the upcoming 2.5 and 2.6 quiz, I'm taking a look at the practice quiz that was posted on Math Excel. Of course, the problems that you'll see on your quiz and on your practice quiz are different, but the context is still the same. So a lot of these problems you've seen, and I just want to make sure that you have an idea on how I would personally solve them, which I think is helpful. So for this problem, we're being asked to solve the equation for y, then find the value of y for each value of x. So this is dealing directly with 2.5 for literal equations. You have your outlines to help you out. You have your notes to help you out. So please refer to those for the steps that ideally you would take. So first, I'm acknowledging that I'm trying to solve my equation for y. So in my equation, I'm trying to figure out where y is. So I know y is right here. So my goal, as mentioned in the video for 2.5, is trying to have y equals something, whatever that might be. So how exactly can I do that? What's on the left side that's not y? Hopefully you're saying 5x. So if we rewrite this, we have y plus 5x equals 8. We can get rid of 5x on both sides by subtracting. This then leaves you with y equals negative 5x plus 8. And so that's what you would want to put in your answer for here. Only takes one step to do it. Shouldn't be too tricky. Next, you're being asked to plug in when x is one of these three values. So when x is negative 2, instead of x, you're now plugging in for negative 2. Be careful with the arithmetic here. I see tons of students get tripped up on this. So notice that this is negative 5 multiplying with negative 2. We're then going to add on 8. But be careful with your arithmetic. So this should be positive 10 plus 8, getting you a total of 18. If x was 0, the outcome would be 8. If x was 4, this would be negative 20 plus 8, because you're taking the product of negative 5 and 4. Negative 20 plus 8 gets you negative 12. There you go. That's the first one. Bam. Second problem is similar in the context because you have to solve for some variable, which in this case is y. Y you know is right here. So let's rewrite this. So we have 3x minus 5y equals 9. Again, our goal is trying to isolate y. I think rewriting this may be excessive, but I think it's helpful. You can subtract 3x from both sides. This leaves you with negative 5y equals 9 minus 3x, or negative 3x plus 9. That's another option. We're then solving for y, so get rid of negative 5 using division. This is going to be your answer. So you should have 9 minus 3x over 5. Make sure it's a negative 5. This equals y. That's what we want. On Math Excel, you can definitely put this in as a fraction, so go for that. The context here is the same with the arithmetic, so when you plug in when x is negative 1, the work for that looks like this. 9 subtracting 3 times negative 1 all over negative 5. The arithmetic here is pretty much 9 plus 3 over negative 5, which can then be simplified to 12 over negative 5. There you go. You can continue in this pattern. When x is 0, the outcome is negative 9 over 5. When x is 1, the outcome is 6 over negative 5. There you go. Fractions, so be careful. But really, all you need to do is focus on the numerator and just keep your denominator as negative 5 and be done with it. This takes us to the rest where we're solving for u. So our goal is to have u equal something. We can get rid of this fraction by multiplying both sides by b. So I'll actually rewrite that over here. So x equals u minus t all over b. I'm multiplying b on both sides. because this will get rid of my fraction. B's cancel. This leaves us with bx equals u minus t. I'm solving for u, so I need to move this negative t over. If I add t to both sides, this is saying that bx plus t equals u, and we're done. And note that this is capital X, so capital X, really crucial. So capital X times b plus t equals u. We're done. The length of a rectangle with width 20 inches and area 146. So this is 20 inches. The total area of this is 146 inches squared. We can get the length of a rectangle by denoting length times width. We're trying to solve for the length. So we already know the width. We already know the area. We can get the length if we divide both sides by the width. So when we plug in with our numbers accordingly, the area was 146. The width was 20. This gets you approximately 7.3. 7.3 sounds about right. So 7.3 inches. So this says you can type in your answer as an integer or a decimal. Decimal is ideal. So you'll want to simplify this further. Make sure you bring your calculator. 5 and 6 deal with 2.6. So this is 2.6. And in essence, you're being asked to take this further and work from this table here, trying to find the unit price. So you can get the unit price if you make a ratio. That's what this section was all about. So eventually you can set up a ratio as far as ounces. Sorry. What would make sense here? Well, you have all of this. You're trying to end up with the unit price per ounce. So you should be taking an increment of money over your ounces. So really, you should be taking whatever the money increment is over 6.2 for this first one, whatever that might be, and then take this money increment 3.33 over 8. Think about what that is. And then you're being asked to figure out which one makes more sense, which in this case is going to be the 8-ounce one. And the reason that is because this is less than this other format. There you go. In this case, setting up 3 individual ratios, the supermarket's surveying to find the best prices, charging for various sizes, find the best price. So you have these sizes, these prices, same song and dance. You're comparing the individual price over the rest of it, so 2.26. And you're comparing here, so you want to see which one's the least, which one's the best to buy. And you're comparing all of these, $4.94 over 48. Setting up the ratios here is going to be make or break. You should be using a calculator on this, and I'll do just that. So we have 2.26, we're dividing by 16, so approximately 14 cents per ounce, which seems all right for salad dressing. I don't know why you would want to buy 48 ounces of it, but I also don't package this, so I don't know exactly how much that is. You see that this is 0.095 per ounce. And finally, you see 4.94 dividing by 48, 10 cents. So it's pretty easy to spot that the 32-ounce one is going to be the best. You don't even have to show work on these. Really, you just have to figure out which one has the less amount. With conversions, we're setting up statements here going from feet to inches. We saw a problem like this in the video for 2.6. So we have 25 feet. That's the main thing that we need to change. And we need to try and put this into inches. So that's the goal that we're trying to set up here. We can keep in mind that we have to go to inches. So we're trying to cancel out feet. And we have 12 feet set up there. We're eventually trying to leave just inches. So 12 inches can represent 1 foot. Eventually, you'll see feet cancels feet. This leaves you with 25 times 12 inches, which is approximately 400. But keep in mind that you're adding on that 6, so it should be 400 plus 6. So you get this 400 plus that 6, 406 inches, and you're done. Sorry, 306. Arithmetic error. As you can see here, it's important to keep in tune with it. Going from hours to minutes, you know that you already have 0.5 hours already spoken for. So you know that this 0.5 you could really just rewrite as 30 minutes, but I'll show you how to do the rest of it. So you have 10.5 hours. You're trying to get rid of hours and you're trying to be left with minutes. So there's 60 minutes in an hour. So you'll see the units of hours cancel. The real arithmetic here is 10.5 hours, or sorry, 10.5. There we go. 10.5 multiplying with 60 minutes. And this leaves you with approximately 630 minutes. And you're done. So notice that the units need to cancel. A lot of the ratios here you should know. So if you need to write those down, do it. Hopefully this video was helpful.